Hey, math doers. This is the second lesson for the week, still working on expressions. So earlier in the week, we looked at categorizing the two different types of expressions and kind of spent some time just even talking about what is an expression. Remember, the expressions do not have an equal sign. They show the relationship between terms. We talked about how expressions contain numbers, operations, and letters to show this. So again, expressions are extremely important in math. It gives us the ability and the knowledge to transfer statements, things that you read, make connections between what you're seeing, and putting it down on paper as an expression using those numbers and operations that accurately describe a situation. Some math statements that we're going to get to a little bit later have real life details, almost like a short story, and you're following along and writing it in a math sentence. Others are simply like descriptions of a math problem. So we're going to start out with basic simple word phrasing and then move on to slightly more complex ones as we get comfortable. All right, so the mathematics, operations, and word problem key vocabulary. So this is kind of a resource that I've created and we've been using throughout the years that we add on to kind of help us with some operational key words that you can look for that indicate certain operations. So just to kind of also show you, I highly encourage you to use this when you are completing your task. To make it more readily available for you, I'm going to actually jump over to our Canvas screen. Let's see if I can shrink that and put it in your range. So this is your homepage of my course. So again, you have the weekly assignments, which I do encourage you to click on the day of the week so that you're receiving assignments with enough time to complete it before the due date. Again, the calendar only shows you the due date, and clicking on the assignments in the dashboard only shows you the due date. So I do encourage you just to kind of, since we have this up and we can talk about it, to come to the course page and click on my daily assignments. Then you also see some good news, like we didn't have any school on Tuesday of this week since election day. All right, so why I brought you this page is kind of more to show you this new tab that I put on the home page. This math resources, when you click on it, you're going to see the document open and be available for you to use. Now it should open into a different page, but this is something that you can toggle. Back and forth from and be able to use when you're completing your assignments. So I wanted to take a minute and just show you where that is accessible on the course page, as well as within the lesson assignment. I'll include it as well, but this would be a go-to place to look for it. All right, so going back to our instruction. So again, here's the keyword charts in there. And again, they list words that mean a certain operation. So for addition, if you see words like increased by, plus, sum, added to, combined with, or total, we are looking at addition operations. The yellow ones highlighted, guys, we're going to talk about a little bit in this lesson. They have kind of an additional implied meaning. So not only does it mean addition, but it may imply that we switch the order of our terms, or there are also words that like doubled, if we move over to the multiplication chart, doubled has an implied number and operation. We know we are to multiply, but we also know double means the value of 2. So we'd be, when you see the word double, you're multiplying by 2. So again, it implies an operation and a number. So to start out, again, we said we would start out basic and kind of dig a little deeper, get more complex. So we're just kind of looking in on the very first section here, just on basic math phrases and our keywords that are more common here. All right, so generally when you write math expressions, you work left to right through a math phrase, replacing words with operators that mean the same thing. So if I look at this very first one, we'll do some examples together. The sum of 8 and y. So the sum means to add. Okay, and if you weren't sure, hopefully that's a more familiar one to you. But again, you can go to your keywords chart and say, oh, here it is, sum. That means to add, so that you know what operation that you are looking at. So the word sum means to add, and we're adding together the two terms that we see next, the sum of 8 and y. So writing it into an expression, there is an addition phrase there, expression 8 plus y. C multiplied by 2. So multiplied, it is straight there forward for you, and it tells you actually to use the word, or it tells you to multiply. C multiplied by 2. Again, if I'm looking to write my expression, I'm going to come on over here and say C multiplied by 2. Now, I will encourage you to not use the X sign because now that we're looking at variables within the problem, it gets kind of confusing. Is it an X? The most common variable used in algebra, right? Or does it mean multiplying? So you've got some options. You can use that little dot like you see to represent your multiplying, or you can also use parentheses to show that operation. So either is fine. Just make sure to not use the X. All right, the next one, the quotient of X and negative 14. Quotient, not as familiar to some people. You could always go back to your keywords chart. But to find the quotient of something, you're looking at multiplying, or I'm sorry, dividing. Quotient means division. What two things am I dividing? X and negative 14. So you can still use the division, good old division sign. That's not taboo in algebra. However, you could also use the fraction bar to show it. So again, I'm writing it both ways just so you can see it. To be honest, guys, in algebra, the second way that I wrote it is a little bit more common. But again, if you choose to use the regular division sign for purposes of not being confused, it totally works. There's nothing it's confused with, so you can go ahead and use that if you need to. All right, and the last one here, the difference between 10 and 3. The difference means the operation of subtraction. And again, whether you know that or you need to look at your keywords chart, the difference is subtraction. And so what two numbers are we subtracting? 10 and 3. So again, generally you just work left to right through a math phrase, replacing words with operators that mean the same thing between the two terms that are discussed. If it states a number, so if we take a look at examples E and F, if it says a number, you can choose any variable that you want to represent that unknown value. Typically in algebra, the most commonly used variable is X, then Y. So either of those variables are acceptable, or again, you could use any letter that you'd like. So twice a number added with 10. Twice a number added with 10. So the first part, here's that word number, right? Oh, let me go back here. So here's the word that we were just kind of talking about. Twice a number. I don't know why that is not highlighting there for me, guys. All right, here's that word number. Now we've got a couple things going on. It says twice the number. So here's one of those examples where twice a number. So again, I'm going to use X for my number. And twice, if you remember back to our keywords chart, was one of those words like doubled. That twice has an implied operation and number. All right, so twice a number, again, has an applied operation and number. Twice a number would look something like this, 2x. There's my number. I chose to use x to represent the unknown. And twice x means 2 times x. And then we're going to add it on with 10. So added with 10. Added straightforward is addition and adding it on with 10. So again, if it has a number, then you can use any variable that you'd like. The second one's a little bit easier. It's asking you to find the product of a number and 5. So again, product means to multiply. What two numbers am I multiplying? N and 5 or X and 5. Any kind of variable would work. Now to kind of talk about it, we could say X5, like we just had mentioned that we work left to right through a math phrase, but there are ones in algebra, especially when you're multiplying a number and a variable. Really, this is the only scenario this applies to. The number typically comes first and the X comes second. We'll talk a little bit about the math properties allowing you to do this and not change the value. Again, X times 5, I would not mark you incorrect, but the more mathematically way to put it would be 5 first and then the X. All right, so however, there are operational words that make comparisons or references in which we have to switch the order of construction, meaning the terms are switched. So the number that came first now is going second, and the number that went second is now coming first. So here are some keywords on the chart that are also highlighted yellow. Those are keywords on your reference sheet that mean that you're going to flip the construction. Usually operational words that signify this are than and from. So let me take you back to our chart real quick and I can discuss those. So again, for addition, it would be more than and greater than are the two most common that you would see. Less than, fewer than, subtracted from, or taken from. those are your subtraction operations where we would flip the construction. And you'll see what I mean by that if you're not sure. And there aren't any really for multiplication and division. But addition and subtraction definitely have keywords that are used that you flip the construction. So let's take a look at those examples. Now I gave you some graphics here as well to hopefully make a little bit more sense to it, because I know we're just talking about numbers and phrasing, so you may hear it, you may not hear it, but if you can put it to some graphics, I think it always helps. All right, so take a look at example G, 4 less than X. Okay, to kind of put some context behind it, let's take a look at those first two pictures of boys. All right, we're going to say that Johnny is 4 inches less or 4 inches shorter than his dad. Okay, so Johnny is shorter than his dad. So in order to kind of come to any kind of answer, I would need to know dad's height first. If I don't know dad's height, I don't know anything, right? So dad is really the unknown. He's the one that is going to make the actual, so we could actually figure out how tall Johnny is, right? So he would need to come first because he is the reference. He is who we are comparing Johnny's height to. So because of that, he comes first, and then we're going to take 4 away from that to figure out Johnny's. So X, 4 less than X, we're going to start with dad, right? He's kind of like the X, he's my unknown. And then Johnny, we said, is 4 less. So X minus 4. All right, let's take a look at this one in the middle, and hopefully this makes a little more sense to you. So our math phrase, our math statement is 5 subtracted from 20. So I like to reference money a lot because it's something you're familiar with. So if I am taking 5, if I say 5 subtracted from your $20 bill, order, which would make sense. If I put it in the order of my problem, 5, right, subtracted from 20. Hopefully you're seeing that doesn't make sense, right? We would actually be starting with my $20 bill, and I'm taking away $5 if I made a purchase. That I started at the day $20 and I subtracted $5 from my 20. So again, that keyword from is something that flips the order of my terms, meaning 5 was original, my problem coming first, and then 20, but I'm switching it, and I would write 20 minus 5 because again, that word from implies that we're switching our operations. All right, last one, 12 more than M, and I'm talking about the length of the rope in these pictures. Again, just to kind of give you some visuals and make sense of it. 12 more than M. Okay, so we're talking about the length of the rope. This guy, Larry Long, let's call him, his rope is 12 more than M. Here's M. There she is, okay? We don't know, again, how long her rope is, but again, it's in reference to her. However long her rope is, we know that Larry Long, he's got another plus 12 on him, right? So again, M is where we're starting. So if I would be writing my phrase, it's M plus 12. All right, guys, so for your assignments, you're going to be looking at just writing basic math expressions for the math statements that you're reading through. There's going to be ones just like our examples where you are going to be working left to right and using that keyword chart to show your letters, your numbers, and your operations. Then there's going to be ones with those terms number, which again, we talked about. You can just use any variable that you'd like. And then there's going to be ones in there as well that are going to have those operational words than and from, meaning that you're going to flip the construction. So use this instructional video to help you along with that key reference chart that I showed you on the course page. Reach out if you need help. Good luck.